Welcome to the BioCyc Metabolites webinar, which will tell you how to search for metabolites in BioCyc and how to interpret BioCyc metabolite pages. Let's begin with a quick search on the compound L-arginine in our current selected database, which is EcoCyc. You can see the phrase matches a number of different object types, but let's move to the compounds section. Quite a few compounds contain that string in their name. Let's click on the one we want, simply L-arginine. We're now on the compound page for L-arginine. The top section lists the name, chemical formula, molecular weight, and monoisotopic mass, and provides a structure. Below that is a tab section that shows different aspects of the metabolite. The summary tab includes the abbreviated name and synonyms, the SMILES, INCHI, and INCHI key strings, a pKa value, and a Gibbs free energy of formation. This value is available for some metabolites, and in most cases it is computed. It also shows us that L-arginine is a ligand for several E. coli proteins. We have unification links on the right that link to this same metabolite in other web-accessible databases that unify the occurrences of this same metabolite. The Ontology tab lists the ontology classes under which the compound is classified. If we click on those classes, we would see other compounds in the same class. The Reactions tab shows reactions that act on this metabolite, organized by their directionality. So here are reactions that consume the compound, and here are reactions that produce it. Note that some of these reactions are generic reactions, meaning that they act on general compound classes that contain this metabolite. These are all generic reactions because L-arginine itself is not explicitly stated. The Regulation tab shows both enzymatic reactions that are regulated by the metabolite, as well as transcription units regulated by proteins that bind to this compound. The Growth Media tab lists growth media that include this metabolite as a component. The References tab lists references cited on the page. And there's the Structure tab, which displays the structure. Finally, the Show All tab shows all data in one long page. Now, commands that operate on compounds are present in this sidebar operations menu. Let's try the command show this compound in another database. And we'll choose Metasyc because we might want to view a compound in Metasyc to see the larger set of reactions and pathways that operate on this compound across all domains of life. And you can see that the reaction and pathway lists are much longer than for the E. coli database. The Search Compounds command on the Main Tools menu will let us do a wider set of metabolite searches than a simple quick search. For example, we can search for metabolites by entering one or more monoisotopic molecular weights and a tolerance value that allows a little leeway in the search. Note that the default database has switched to Metasyc, but that's okay. I'm going to paste in 2 monoisotopic molecular weights, and it will submit my search. And the results show 2 sets of compounds, those that match the first molecular weight and those that match the second molecular weight. Most of these are isomers of one another, and those that match Most of these are isomers of one another. They all have the same molecular weight. And I could click on any of these compounds to go to the compound page. And we can sort any of these columns by clicking the little triangles. Now, if we go back, we can explore some of the other searches available. Another kind of search we can perform is by chemical formula. Now we can do either a partial match or an exact match. Exact match means the compound we match has to have exactly the same formula. The partial match says it has to contain exactly the elements we specify, but may contain additional elements as well. So for example, C12 will return all the compounds that have exactly 12 carbons and perhaps some other elements. And here are our 612 results. We can also do a chemical substructure match. For example, if we enter this string, this smile string will match a chain of 6 single-bonded carbon atoms that end with a double bond to oxygen. Let's submit that query. And the SMILES query returns some 4,900 results. We can also combine the SMILES string and the chemical formula filter by specifying both the SMILES string and the chemical formula, and any matched compounds have to satisfy both of those filters simultaneously. And here are the 109 compounds which match both criteria simultaneously. Finally, I'll point out that we can extend our research across multiple organisms and databases by using the checkbox at the top as we discussed in the search webinar.